Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be talking about one factor that influences the reaction rate. Né? Please do note that guys, each and every factor that influences the reaction rate will have its own video, just to avoid having long videos. Né? So on this video guys, we are just going to focus on temperature. Are you together? On how does temperature affect our chemical reaction, right? Okay, we are told that learners used two experiments to investigate the influence temperature has on the reaction rate. They react calcium carbonate with hydrochloric acid in their investigation. The balanced equation of the reaction is given below. Okay, and then we are told that the table below shows the conditions of each experiment. Okay, both experiments have the same state of division of calcium carbonate. They are both in powder form. And secondly, the concentration of our hydrochloric acid in both experiments is the same. The only difference over here is the temperature. Are you together? If you asked probably which one of if you asked rather to write down the independent variable for this investigation, you would have simply said temperature is our independent variable. Are you together? Because our independent variable is the variable that we keep on manipulating. We are just changing the temperature. In turn, we want to know how does it affect the rate of a chemical reaction. Are you together? So in here guys, I want to know how does an increase in temperature affect my chemical reaction. Are you together? Okay, and then obviously guys, the dependent variable, whenever you're dealing with rates of reactions, your dependent variable is always your reaction rate. It's always the time. Your independent variable is just one of the factors that influence the rate of reaction. So since over here guys, we're investigating about temperature, it simply means our independent variable is temperature. Okay, which experiment has the highest reaction rate? Use collision theory to justify your answer. The one that has the highest reaction rate is the one that occurs at a higher temperature. Are you together? So my answer will be simply be experiment 2. Experiment 2 will have the higher reaction rate. Why? Because experiment 2 occurs at a higher temperature compared to experiment 1. Are you together? And why do I say so? I'm supposed to use collision theory now to justify my answer. Let's assume that guys, experiment 1 was just our given reaction, and then for us to investigate, we then changed our temperature in experiment 2. We increased our temperature. We'll simply say that an increase in temperature. Now guys, I'm answering by using collision theory. An increase in temperature. Are you together? An increase in temperature will increase the kinetic energy of our colliding particles, of colliding particles. Are you together? So whenever guys we increase the energy of colliding particles, it simply means that now more colliding particles rather will have kinetic energy which is greater than the activation energy. Are you together? Now we'll end up having more particles having a kinetic energy which is greater than the activation energy, and hence we'll end up having more effective collisions. And that is why experiment 2 has a higher reaction rate. A higher rate of reaction. Are you together, guys? Okay. So an increase in temperature, guys, will always increase the kinetic energy of our colliding particles. Are you together? If we increase the kinetic energy of our colliding particles, it simply means that now more particles will have kinetic energy which is greater than the activation energy. This is one of the conditions for effective collisions. Are you together? So if now more colliding particles have kinetic energy which is greater than our activation energy, it simply means that we will have more effective collisions per unit time. Are you together? And obviously, if there are more collisions per unit time, that simply means the rate of reaction will increase. That's how, guys, you predict your reaction rates by just using a collision theory. Are you together? Please note that whenever you increase temperature, guys, I'll repeat, whenever you increase temperature, you will always increase the kinetic energy of your colliding particles. Are you together? And obviously the opposite is true. If you decrease temperature, you will always decrease the average the kinetic energy rather of your colliding particles. Are you together? So please, guys, keep that in mind, you know? Okay. Over here, guys, we are being told that the sketch below illustrates the Maxwell-Boltzmann distribution curve. Okay, I know that, guys, I didn't say much about the Maxwell-Boltzmann distribution curve, né? But please note that for the basics, né, on your y-axis, you're just representing the number of particles. The number of particles, né? I'm lazy to write over there. And then on the x-axis, that's kinetic energy. On your x-axis, you're representing kinetic energy, né? And there are two things I want you to note about the Maxwell-Boltzmann distribution curve. Firstly, the peak over there just represents your average kinetic energy. Are you together? And then that black line over there represents your activation energy. Are you together? Such that, guys, the particles which are over here are the only ones which will have effective collisions. Why do they have effective collisions? Because their kinetic energy is greater than our activation energy. Are you together? But the ones that are on the other side, let me use a different color. The ones that are on the left hand side of our activation energy will not form effective collisions. Why? Because their kinetic energy is less than our activation energy. The only particles that will form products are these ones over there, because they have a kinetic energy that is greater than the activation energy. Remember that, guys, I said that one of the conditions for effective collisions, the particles should always have kinetic energy that is greater than the activation energy. Are you together? So that will happen over there, né? Okay. Whenever, guys, we increase temperature, now let's go back to our question. Let's forget about this. I was just explaining the basic part of Maxwell-Boltzmann distribution curve over there. Now let's go back to our question. We are being asked which curve A or B represents reaction 1. Reaction 1 is the one that occurs at a lower temperature. Okay. Whenever, guys, my reaction occurs at a lower temperature, number one, the average kinetic energy of my particles will be lower. Are you together? So reaction A, remember that, guys, on the x-axis you increase if you further move towards the right. Are you together? So this average kinetic energy over here is lower than this one. Are you together? So I can simply conclude that curve A is the one that represents experiment 1. This one represents experiment 1. Are you together? And then curve B will represent experiment 2. Are you together? Curve B will represent experiment 2. But if you check, guys, as well, né? For experiment Y, these are the number of effective collisions. We just have a small area over there whereby we can find effective collisions. Ne? But for experiment 2, since experiment 2 occurs at a higher temperature, this will be the number of effective collisions. Do you see that now we have a greater area of effective collisions? That area, guys, it represents the total number or the total volume of our effective collisions. Are you together? Such that for the green curve, we have more effective collisions compared to the blue curve there. Ne? So this simply means that the green curve represents the reaction that took place at a higher temperature. Now guys, you know that, okay, whenever you increase your temperature, the first thing that will happen to your Maxwell-Boltzmann distribution curve is that your peak will be lowered. Initially, at a lower temperature, the peak was up there, but right now our peak is lowered down there. Are you together, guys? The peak will just be lowered down there. And secondly, the average kinetic energy has increased from this value to that value over there. Why is the average kinetic energy increasing? Because by increasing temperature, guys, you will increase the kinetic energy of particles. And with an increase in the kinetic energy of particles, that means the average kinetic energy of our particles will also increase. Are you together? And then obviously, guys, with the higher temperature, we'll end up having more particles colliding. That's why the area over there is big. Ne? But to answer the question, we're being asked which curve, A or B, represent experiment 1. Curve A represent experiment 1. Why? Because it has a higher peak, number 1, a lower average kinetic energy, number 2. Number 3, it has less effective collisions. And that's true because reaction 1 occurs at a lower temperature compared to reaction 2. Okay, and then now we are told that the graph below shows the formation of carbon dioxide. Then we are being asked which curve, P or Q, will represent experiment 2. Remember that, guys, experiment 2 occurs at a higher temperature. Are you together? So experiment 2 will simply have more effective collisions. Are you together? So since experiment 2 will have more effective collisions, it simply means that experiment 2 will have the highest volume of our product. Are you together? So this curve over here, this curve that was P and Q, ne? Curve P is the one that represents experiment 2. Are you together? And then curve Q is the one that represents experiment 1. Are you together? Even if, guys, you didn't check the quantity, by just checking the steepness of your curve, are you together? The red graph is more steeper than the green graph. Are you together? Whenever your graph is more steeper, it simply means that your rate of reaction is higher. And even if you check here, guys, for the red graph, completion was reached after 4 minutes. Are you together? Whenever, guys, your graph of formation is starting to be flat now, that simply means that your reaction has reached completion. There are no more products which are being formed. Are you together? But it took the other curve to reach completion after 8 minutes. The one that takes more time to reach completion is the one that has the lowest rate of reaction. The one that takes the smallest amount of time to reach completion is the one that has the highest rate of reaction. Are you together? So in this case, guys, our experiment P, our curve P is the one that represents experiment 2. Are you together? That's experiment 2 and that's experiment 1. Okay, and then now we are being told that the total amount of volume of carbon dioxide collected in experiment 1 is basically 245 cubic centimeters. They want us to calculate the rate of reaction in grams per second if 1 mole of gas occupies if 1 mole of gas occupies, or rather occupy, one mole of gas occupy 24.5 cubic decimeters at 25 degrees Celsius. Okay, they want us to calculate the rate of our chemical reaction, né? And they are telling us about the product. Remember that, guys, I said to you that the rate of reaction on our introduction video rather, is the change in the quantity of products all over the change in time. Are you together? So since we are supposed to calculate our rate of reaction in grams per second, that means I'll simply use the change in mass of my products all over time, né? So since I'm given the volume of my gas that was collected, I'll simply change that volume into number of moles. After changing the volume into number of moles, I'll simply change it into the mass and then find my reaction rate. Let's just do so. I know that the number of moles is equal to volume of a gas, the actual volume of a gas divided by the molar volume, né? Please make sure that, guys, whenever you use this formula, né, both your volumes are in cubic decimeters. So I just need to change the collected volume to be in cubic decimeters. I'll simply divide by 1,000. I'll end up having 0.245 cubic decimeters divided by 24.5 cubic decimeters. And then this should give me the number of moles of my carbon dioxide that were formed. 0.245 divided by 24.5, this will simply give me 0.01 moles. I now know that, okay, the number of moles for my carbon dioxide, I simply have 0.01. Now let me calculate the mass of my carbon dioxide that was formed. Number of moles is equal to mass all over the relative atomic mass number. Are you together? I have 0.01, that's mass divided by carbon dioxide. Carbon is 12, and then remember that, guys, carbon dioxide is CO2, né? Carbon has a relative atomic mass number of 12, and then oxygen has a relative atomic mass number of 16. That's 12 plus 16 times 2. Therefore, the mass is 0.01 multiplied by 12 plus 16 times 2. And then this will simply give me an answer of 0.01 multiplied by 12 plus 16 times 2. This will simply give me the total mass that was formed to be 0.44. So I now know that the mass of carbon dioxide that was produced in experiment 1 is just 0.44 grams. Are you together? So for me to calculate the rate of reaction, I'll simply say that the mass, the change in mass is equal to the final mass, which is 0.44, that we find after completion. But initially, there was no amount of carbon dioxide in our reaction. So we simply had 0 divided by the amount of time. It took 8 minutes for us to fully form this carbon dioxide because the reaction reached completion after 8 minutes. Remember that, né? So we must just convert the 8 minutes into seconds. I'll simply say 8 multiplied by 60. So our rate of reaction is just 0.44 divided by 8 multiplied by 60. So this will simply be let me put my thing into scientific notation, scientific mode. That's just 9.17 times 10 to the power negative 4 grams per second. Remember that, guys, I was forced to change my time into seconds because I was told to find my reaction rate in grams per second. That's how, guys, you deal with temperature, temperature's influence in a rate of reaction. Né? The most important part, guys, of this video was this one over there. Knowing how to apply collision theory, and obviously from your grade 11, I'm assuming that doing these calculations is quite easy for you. Né? from your grade 11. Just doing these calculations is quite easy for you, and then obviously apply whatever answer you get to your rate of reaction, and then we are cool. Just stay tuned, guys, and wait for more videos. Thank you.